This is our fourth class on integration, and today we are going to discuss a broad topic which is a very useful topic. That is, we are going to discuss some special integrals, and also we are going to discuss some problems which are not given directly in the special form, but we have to reduce it down to the special form. So let us begin. Now let us take this integral, that is integration dx by under root x square plus a square. Now we will be trying to just work out what this integral is. Now obviously, to solve this we require some substitution, and the best substitution we can take is taking x as a tan theta. So if we take x as a tan theta, then dx becomes a sec square theta d theta. Now putting all the substitution into the problem, this is what we get. So dx is a sec square theta d theta, and x is a tan theta, so x square is a square tan square theta. So it comes out to be a sec theta, and a gets cancelled, sec theta and the sec theta in the numerator, one of the sec theta gets cancelled, so you are left with integration of sec theta d theta. Now we know that integration of sec theta d theta is log of mod of sec theta plus tan theta. So if x is a tan theta, then tan theta is x by a, and sec theta will be under root x square by a square plus 1, because we know that sec square theta is 1 plus tan square theta. So therefore this is what you get. Now if we just take LCM and bring everything out, we will have a log a coming out. So how it does come out, let me just show you a small step. Now obviously from here what we will get log of mod of x plus under root x square plus a square by a. Now obviously we know that log of m by n, that is equals to log m minus log n. So therefore this becomes log of x plus under root x square plus a square minus log a. Now log a is a constant, and we already have a constant of integration, that is c. So we can cumulate this and we can write this as some c dash, now which still remains a constant. So therefore my integration becomes log of mod of x plus under root x square plus a square plus c dash. Fine. So now this c dash and c, they hardly matter because they are all constant. Next, let us take another one. Dx by x square plus a square. Now in this case again we are going to take the same substitution, that is x is equals to a tan theta. Now obviously then again dx becomes a sec square theta. So if we put everything in, we have a sec square theta d theta by a square tan square theta plus a square. Now that gives you a square sec square theta. Now a will get cancelled, sec square theta gets cancelled, so there will be 1 by a, which is a constant coming out of the integration, and you will have integration d theta. So therefore that is 1 by a into theta plus c. Now what is theta? Theta is basically tan inverse x by a. So therefore your answer is 1 by a tan inverse x by a plus c. So now if we go on doing this kind, if we do integration in this pattern, we can see we will have 6 different types of integration, and they are the special integrals of type 1. There will be another special integral of type 2, so we will be dealing with that later. So in the first set of special integrals, which are your standard integrals, we can use this formula without proving them. We need not prove them, we can directly use the formula. I just shown you that how these formulas come. So let us just see what those are. So let us take the first one. So first one is basically what we did. So integration dx by x square plus a square, that is 1 by a tan inverse x by a plus c. Second one is dx by x square minus a square, that is 1 by 2a log of mod of x minus a by x plus a plus c. Third one, integration dx by a square minus x square, that is equals to 1 by 2a log of mod of a plus x by a minus x plus c. Next, integration dx by under root x square plus a square, that is equals to log of mod of x plus under root x square plus a square plus c. Next, integration dx by under root x square minus a square, that is log of mod of x plus under root x square minus a square plus c. And the last one, integration dx by a square minus under root a square minus x square, that is sine inverse x by a plus c. So you can always go through the proof. If you once go through the proof, what happens? It will become easy for you to remember the formula instead of mugging them up. Now let us take few problems and solve and understand how to apply this. The first one, simple one, integration dx by dx by x square minus 16, so which is directly in the formula. So we will be just starting off with this. Now 16 can be written as 4 square, so therefore this is in the form dx by x square minus a square, so that is 1 by 2a, that is 1 by 2 into 4, that is 1 by 8 log of x minus 4 by x plus 4. So that is your answer. Basically that's it. That is our answer. Let us move to question number 2. Integration dx by 25 plus 9x square. So here we have to do a little bit of work. What work we can do? So integration dx by 25 plus 9x square, that's what is given. So I can write this as dx by 5 square plus 3x square. Now obviously we have to ensure that the variable is standalone, there is no coefficient with it. If we have a coefficient, we can take a substitution or we can divide it out and we can take it out of the integration. So there are two ways of doing it. So here I am doing a substitution which makes it easy. So 3x is z, dx is equals to dz by 3, and this becomes 1 by 3 dz by 5 square plus z square. Now this is in the form dx by x square plus a square, so this will be 1 by a tan inverse x by a, so 1 by 3 is already outside into 1 by 5 tan inverse z by 5. So z is something which we have taken, so we will be turning it back to our original variable, that is x. So your final answer is 1 by 15 tan inverse 3x by 5 plus c. Fine. Next, number 3. Number 3, we have integration sec square x by under root tan square x plus 4 dx. Now this is one of the integration which is not given directly in the form, but we have to reduce it down to one of our standard forms. So for this, let us consider tan x as z. So if I consider tan x as z, then we have sec square x dx as dz. Put it back into the integration. We have dz by under root z square plus 4, as simple as that. Now obviously this is in the form dx by under root x square plus a square, where a is 2, 2 square is 4, so therefore this is log of mod of z plus under root z square plus 4 plus c, but z is tan x, so we just put tan x in place of z, and this is our final answer. Next, number 4. Number 4, integration sin x plus cos x by 9 plus 16 sin 2x. Now this problem is a very typical problem of its kind, and there are several problems of this kind which you will find. So now we have to reduce it down to one of the forms and then we have to integrate. So let's see what to do. Now before we can take any substitution, we have to first take it into a certain form. So this is how we start. So sin x plus cos x as it is, in the denominator we can write 9 as 25 minus 16. We always can write. Why we are writing this? Let us see why. Now in the next step, let us take 16 common from the two terms we have. So it becomes 1 minus sin 2x. Now 1 can be written as sin square x plus cos square x, we already know, and sin 2x can be written as 2 sin x cos x. So I haven't shown the step because it is a very trivial step to show, but let me just show you separately. Hold on. So 1 minus sin 2x, that can be written as sin square x plus cos square x minus 2 sin x cos x, which is basically in the whole square form. So that is basically sin x minus cos x whole square. So these steps are not required to be shown because you have already done trigonometry in class 11 and these are very trivial trigonometrical problems. So you may not, if you can do it directly, it's very good. Otherwise, you can show the steps if you want. Next. So from here, what to do? See, let me take sin x minus cos x, or rather 4 sin x minus cos x. Why 4 sin x minus cos x? Because I have 16 sin x minus cos x whole square. So it is 4 into sin x minus cos x whole square. So let me take 4 sin x minus cos x as t. Then sin x plus cos x dx will become dt by 4, right? So let us put all these into our integration. So the numerator becomes dt by 4, so that 1 by 4 comes out, and in the denominator it becomes 25 minus t square. So this is basically dx by a square minus x square, a being 5, 25 is 5 square, so a is 5. So therefore this is 1 by 2a log of mod of a plus x by a minus x. So therefore this will become 1 by 4 into 1 by 10, 1 by 4 into 1 by 10 log of 5 plus t by 5 minus t plus c. Now obviously t is something we have taken, so we have to change it back. So therefore I have my final answer, that is 1 by 40 log of mod of 5 plus 4 of sin x minus cos x by 5 minus 4 of sin x minus cos x. So therefore this is our final answer. So once you go through it, you will understand that first I need to take it to a form where I can see that it is coming into that one of the 6 forms, and then I will be taking substitution if necessary. Next, number 5. Problem number 5. Integration dx by 2 minus 3 cos 2x. Another problem where it is to be reduced. So let us start. So what we can do, cos 2x, I can write it as 1 minus tan square x by 1 plus tan square x, as we know. This is the formula. Now, obviously, 1 plus tan square x goes in the numerator after taking LCM, and after taking LCM it becomes 5 tan square x minus 1. Just do your LCM. This is a very basic step. I haven't shown the step. Now obviously I need to take some substitution. Now 5 tan square x, that can be written as root 5 tan x whole square. So let me take root 5 tan x as z. So if I take root 5 tan x as z, then sec square x dx becomes dz by root 5. Then putting all this in, I have 1 by root 5 into integration dz by z square minus 1. Now again this is in the form dx by x square minus a square. So this will be 1 by 2a, that is 1 by 2 log of mod of z minus 1 by z plus 1 plus c. But again z is our root 5 tan x. So root 5 tan x minus 1 by root 5 tan x plus 1 plus c. Right? So the only trick or the only difficult part in the problem is to understand what what property I need to use to ensure that it comes into that integrable form. Because once it comes to the integrable form, then taking substitution and integrating is definitely not that difficult. Number 6. Problem number 6. Integration dx by x square minus 4x plus 8. Now this is an integration which is of the form, as you can see, this is an integration which is of the form dx by ax square plus bx plus c. Now obviously this type of integration or integration dx by under root ax square plus bx plus c. So these are the two forms which can be reduced down to one of those 6 forms. Now this is one of those types. So let us see how to deal with such problem. Now my first job will be to write ax square plus bx plus c into x minus alpha whole square, means a whole square term plus some constant square. So we have to represent it in this form. This is how we represent. So first I need to do that, or it can be written in the other way also. It can be obviously alpha square plus x minus beta square, or alpha square plus minus. Here I am putting a plus minus because I don't know which form is going to come, but it will be obviously here also it is a plus minus because I don't know again which form I am going to get. So I have to represent it either in this form or in this form, in whichever of the two, or rather whichever of the 4 different forms that I get. Right? Okay, so let us see what we can do. So I can see that x square minus 4x plus 8, I can write this as x square minus 4x plus 4 plus 4. Now obviously from here I can see this part is a whole square, that is x minus 2 whole square. So let me just write that. So that's it, and plus 4 is basically 2 square. Now x minus 2, I have to take a substitution, let that be z, and then dx becomes dz. So let me just put it back. So it is dz by z square plus 2 square. So that is tan inverse formula. So 1 by 2 tan inverse z by 2 plus c. Now z was x minus 2. So let me put that back, and that is your answer. Now obviously if you can do it directly without taking that substitution, so I mean if this step is clear to you, you don't require to take a substitution, you can see what the answer is going to be, you can definitely write the answer directly from here, so no issue. But at the beginning it is always good to take an substitution, because if you take a substitution, there are less chances that you will get it wrong. Fine. Next, number 7. Integration dx by under root 9x minus 4x square. So this is also again in one of those forms. So here what to do? I have to bring that whole square form. Now this is something you have done in your junior classes, something known as completing the square. This is a technique which we have done when we were doing quadratic equation. So if any quadratic equation is there which is not in a square form, then I first try to add or subtract something so that it comes in the quadratic form. So therefore, see, I was given 9x minus 4x square. So if I can see, I am writing this 4x as 2x whole square. So this is one of the a square. Now this 9x will act as 2ab. So I need some b square. So 9x can be written as 2 into, I need this 2x here. So 2 into 2x. Now obviously I can't add or subtract anything, so therefore it will be 9 by 4. So 9 by 4 is your B, so I have to add and subtract 9 by 4 whole square, that is your 81 by 16. So that's exactly what I have done here. Now this is something which is very basic thing if you have forgotten, so that is why I'm explaining it once again. But you should not forget this, because this is now have become a basic tool. Completing the square method is now a basic tool for you, because you already did it in junior classes. So therefore this is basically what we have done. Now, so from here what we can see, that this whole thing becomes a whole square term, and this is your whole square, 2x minus 9 by 4 whole square, and 81 by 16 is your 9 by 4 whole square. So this is in the form dx by under root a square minus x square. But obviously 2x minus 9 by 4, I need to take this as a substitution, so let me just substitute it. So 2x minus 9 by 4, that is taken as z, so then dx becomes dz by 2. Put it back, then it becomes half into integration dz by under root 9 by 4 whole square minus z square. So this integration will become basically half into sine inverse z by 9 by 4, so that is 4z by 9. But z is something we have taken, we chose it for ourselves, so therefore I have to substitute it back. So z is 2x minus 9 by 4 multiplied by 4, it becomes 8x minus 9. So therefore this is your final answer. Now let us move to the last problem. The last problem being integration 5x plus 3 by root over of x square plus 4x plus 10. Now this is another different type of integration. This integration type is integration px plus q by ax square plus bx plus c, or it can be your integration, or it can be integration of px plus q by under root ax square plus bx plus c. Now both the types are very important types, and they are very big large problems, so they can come for 6 marks. Now these are pretty much part of your syllabus, not mentioned in the syllabus explicitly, but definitely it is there mentioned that there are special integrals, so these are part of the special integral problems. So now how to deal with such problems? So let us see how we deal with this kind of problem. So what we have to do first, so you are given say px plus q by by ax square plus bx plus c. So this is what you are given. So what I will try to do, I will try to write px plus q as some lambda times derivative of ax square plus bx plus c. So lambda times ddx of ax square plus bx plus c plus some constant mu. So I have to represent this in this form. So this is basically how you do it. Be it without under root or be it with under root, doesn't matter. In both the cases, I have to ensure that I write the numerator part, like here this is the numerator part. I have to ensure I write the numerator part as some constant times derivative of the denominator part, that is this, plus another constant. So this is how we have to represent. So this is the first step of solving the problem. So let us see how to do it. So what is the derivative of x square? What is the derivative here? So here the derivative is 2x plus 4. So what my job will be to write 5x plus 3 as some lambda times 2x plus 4 plus some constant mu. Now obviously you can solve the equation to find the value of lambda and mu. You can do it in that way, or you can just try to use the trial and error method to write it, which in this case I have done using a trial and error method. See how to use the trial and error method. 5x plus 3, this is what you are given. So can I take this 5 common out and write this as x plus 3 by 5? See, I can write this. Then I can write this 5 as 5 by 2, just excuse me once, I can write this as 5 by 2 into 2x plus 6 by 5. See, I can write this. Then this 2x plus 6 by 5, I can write this as 2x plus 4 minus 4 plus 6 by 5. So therefore this 2x plus 4 into 5 by 2. So this 5 by 2 becomes your lambda. This 2x by 4 comes here. And this part becomes your mu. Multiplied with 5 by 2, of course. It becomes your mu. So therefore, this is called the trial and error method of finding the values of lambda and mu. Or you can solve it by putting in the equation and then find the value of lambda and mu in whichever form you do it. But always remember, if you can do it using trial and error method, that becomes much easier because you don't have to do an extra step of solving any equation. Fine. So let us write this, see what I am writing. So this is exactly the first step. Taking 5 by 2 common out, I can write this as 2x plus 6 by 5. In the next step, I can write this as 2x plus 4 minus 4 plus 6 by 5 again. Then see, there will be certain, I just break out the two integrations. So taking 2x plus 4, taking this 2x plus 4, this is one integration, and taking this part, this is the other integration, right? Now we have to integrate. So hard part is done. So half of the job is already done. Now our job will be to do the integration. So now we can see both the integral are in integrable form. We don't have any more trouble. So now let us start integrating. Now in the first integral, this is your z. If you consider this as z or z squared, then this whole thing becomes dz or 2z dz, whatever. And in this part of the integral, what we have to do? We have to write the denominator term in the whole square form, and then we have to integrate. So let us see what we are doing. See this. Here I have written this as x plus 2 whole square plus root 6 whole square. Fine. Let me just cut this out. This was blocking the view. So this is what we can write. Then for the first integral, let me consider x square plus 4x plus 10 as z square. Then definitely 2x plus 4 dx becomes 2z dz, and we will put it inside the integral. So let us put it. So if I put, see, this is what happens. So a lot of things get cancelled, and the second integral we have already done the integration, and this is what the integration comes out to be. So z gets cancelled, 2 gets cancelled, and you are left with integration of dz. That becomes z. But what was z? Obviously you took x square plus 4x plus 10 as z square, so z will be under root of this. So this is 5 into under root of this quantity minus 7 log mod of x plus 2 under root of x square plus 4x plus 10. So as you can see, this type of problem, if you are given, then there will be some some manipulations to do before you can start integrating. So therefore, go through the step, practice a few problems, and I'm pretty sure you will be able to solve it. Fine. So thank you so much. This was our class, and we will meet once again on Friday or Saturday for the next class. Thank you.